Hello, welcome back. Now we are deep into the work done, making use of work energy. They were trying to solve some of the concepts, and I think I started with the gravitational potential energy, particularly for chains, ropes, and strings. It's something that I think I worked out last time, where I took the chain to have a linear density dm by dx, right? Now, if you take it as a constant, what do you get? If you take it as a function, what do you get? Etc. We saw the chain problems are slightly different, but I want you to be careful. While doing the chain problems, I might even probably get into the other part of that. Where to use work energy theorem, where not to use work energy theorem. In fact, the other day I told you that you have, this is the chain, and once the chain is released, by the time the last link leaves the chain, what will be the velocity of the chain? That's what I tried to find out. If lambda is constant and if lambda is kx. Now the question is, this I could make use of work energy theory because there is only one force that is doing work, that is gravitation. Say for example, I am now taking a case likewise. This is L I take. The entire length of the chain is capital L. Total length of the chain is capital. Now if I release that, the whole thing will fall. By the time the last link leaves, what is the velocity of the chain? But this part that is touching the ground. So as soon as it touches, so that part doesn't have any velocity whatsoever. Okay? Now here, very difficult to use work energy theorem because not only gravity, but some other force is also acting, making that last chain's velocity, last link of the chain, the velocity to be zero. So you cannot get into work energy theorem here. Because the work done by that force is not known as gravity, I can find out. Spring I can find out. Friction I can find out. But this is something that I cannot. Now what do you do? In such cases, don't use, I am very clear in this, don't use work energy theorem. What should you do then? Why should this whole chain come back? It's because weight of this chain is pulling the entire chain. What is the weight of this chain? It is L at this stage. At any time it's L only. So at one stage, let us say X is lying on the top of the table, smooth table. So L lambda is the force that is pulling. How much of L it is pulling? The same L lambda into G, Mg is pulling, and that is, what is this? L plus X. Are you finding, L plus X into lambda, into, this is the mass of this chain, into acceleration. How do I write the acceleration here? L plus x lambda a v dy by dx. Remember, as x decreases, v increases. As x decreases, v increases. Therefore, dv by dx is negative. Got the point? This is what I am going to make use of it here. So, likewise. So, this is L and G. Now, lambda gets cancelled. Now, you have LG by L plus X, LG by L plus X, dx is equal to V dV. This my negative sign I brought into the other side. I am now making use of Newton's second law here. Your Kennedy theorem was also from Newton's second law. But there you are using the work and all the forces involved. And here you can't because I don't know. Therefore, and initially this is 0, finally V. Initially, what is X? L minus L. Finally, what is X by the time it comes here? 0. So, negative sign, if I remove, I can interchange the limits. So, what do I do? LG you can take out dx by L plus X. LG into the limits is 0 to L minus L, and that is integral V is V squared by 2, initially 0 velocity, right? Now, you see, this is 1 upon x form, that is ln L plus x. Where to where? 0 to L minus L, that is V square, 2 I am bringing on to this side, 2GL, Ln, this is L minus L plus, I will put it for you, minus Ln L plus 0, so that you won't have any issue. So, L gets cancelled, there is 0. So, 2GL Ln L by L under root. See how much is the difference in these two problems. You have to be very, very careful in working out this because its velocity as soon as it touches that road is becoming 0 and there is no heap of the state because the potential energy will differ there in such cases. Is this clear to you? I hope right. So this is one problem, concept based on this. Now with the same thing, I will go into a little more complication. Suppose I have a maximum possible hanging length of the chain. Here there is friction. It doesn't touch the, maybe I will give you here so that you won't have any issues at all. What do you mean by maximum hanging length? Suppose, let's say the whole length is L. Let this be Y. So that this is L minus Y. L minus Y, lambda is the mass of this into G weight of this. This is balancing this frictional force there. What is the frictional force here? Y lambda G is the normal force into mu is your frictional force. So this is a simple version of y lambda mu g. Lambda g gets cancelled. And if you want to know how much is lying on the surface, you have got y into 1 plus mu is equal to L. This is the part lying on the table. And what am I interested in? What is hanging? So, L plus mu L minus. So, this part is, and this part is how much? L by 1 plus mu. Right. Now, I have taken a case where I'm going to erase this. I'm going to take a case where maximum possible hanging length. Okay, this one. Why? If I slightly pull it, the whole thing will fall off. Yeah, you can use even Newton's second law also here, but work-entry theory is more easy here because there is no force whose work done is not known to us. Therefore, I have no issue at all. What do I do? Now, what is the work done? First of all, this is my reference level. I can do it in two ways. Okay, number one, work done by gravity plus work done by friction is equal to change in kinetic energy. That is one way. The other way is the change in potential energy. Whatever the decrease is there in that is converted to, that means decrease of gravitational potential energy is converted to 1/2 mv square kinetic energy of the whole body plus work done against friction. Against friction means minus Wf. But Wf is negative. Both are one and the same, remember. There is no difference whatsoever. It all depends on how you view the whole thing from a fundamental perspective. Now let us see. Now, I think I already did this problem before with the potential energy to be zero there. What is the initial potential energy of this? I think we have worked out that it is, I'll take it as L minus y lambda into g, that is mg into the length by 2. This is with a negative sign. Why? This is below this and this is uniformly distributed, so I have no issue of working out this. Therefore, I have L minus y whole square lambda g by 2. This is initial potential energy. What is the final potential? When the whole thing is hanging, last link leaves the top of the table, then you have the total length is L by analogy, because that is also below the whole thing. Okay? Now, if you want to know what is work done by gravity, always remember, change in potential energy is final minus initial. Work done by gravity means initial being minus final. So how do you get that? I will write down here, work done, let us say by gravity is PEI minus PEF. So what do you get here? L minus y by 2 minus of minus L square lambda G by 2. This is the work done by gravity. Right? That means what do you get here? L square lambda G by 2 minus L minus whole square lambda G by 2. This is work done by gravity. Fine. What is the work done by friction? Now this is important. Look, work done by friction you have to find out. Suppose the X part is lying on the table. What is the frictional force kinetic? Because it is moving, it is kinetic frictional force. The kinetic frictional force is mu mg. Mg acting, so normal force is a mu times n is the frictional force. So Fk is this. What is the work done by frictional force? Fk dot dx. Fine. Fk dot dx. So Fk is like this. Okay. Fk is acting. But actually x is also decreasing here. So let me put it so that you will understand. Mu x lambda g dx. Here dx is negative. Dot means cos 180 minus 1 negative. So both are negatives, therefore you get like this. Right? This is the work done by friction is mu lambda g into x dx. Yeah, where are you going from? Initially how much? L minus. Finally 0. So what are you getting? Mu lambda g x square by 2. So minus L minus y whole square. Mu lambda g by 2. This is work done by friction. You see, you will automatically get negative. You have to. That is minus of L minus y whole square mu lambda g by 2. This is work done by friction, work done by gravity. Lambda g by 2 constant. So have L square minus L minus y whole square. Okay? Now the sum of these two is equal to the kinetic energy. So I will write lambda g by 2 on this minus y2 is equal to half. L lambda is the total mass. V square. Now 2 gets cancelled everywhere. Lambda gets cancelled everywhere. Now what do you get here? You have to find out. I will do this thing here for you. Alright. So V square is equal to G by L. This L I am bringing in. And now the whole thing I have to take care of. Here probably you can write what is L minus y. L minus y is mu L by 1 plus mu. Both you have got it, so it is straightforward. Right. So what do we do? L square minus this whole square. Mu square L square. No, there is a problem here. I think L minus y What did we take as y? Its y is lying on the table. I got L minus y hanging. The hanging part is L minus y. That's right. Mu square, L square, that's U square, minus L minus y whole square. Mu into L minus y whole square. Mu square is 1 plus mu whole square. Okay? If I take it, now L square is common, so you get L square. So L gets cancelled, GL. Now you have 1 minus mu square by 1 plus mu whole square minus mu cube by 1 plus mu whole square, mu cube by 10. Now, GL. Now from these things, 1 minus mu square by 1 plus mu whole square is common. So 1 plus the mu you will get. So you will get that also cancelled. So GL into 1 plus mu minus mu square. This is V. This is how you are going to get the expression. But I want you to try this on your own. If I have committed a mistake, you have to verify that L minus y, which is your hanging length, that's what we took. I have my own doubts about this. I'll try to put it for you. This one, if I take it as y, this is L minus y. L minus y lambda g, mg is balanced by, what is this? Mu y lambda g. So lambda g gets cancelled. L is equal to y into 1 plus mu. And so what is y? Y is equal to L by 1 plus mu. Why you got L by 1 plus mu? Okay? Now I think so what are you getting here? L minus y is L minus L by 1 plus mu. So L into 1 plus mu minus 1. So you have L mu by 1 plus mu. Okay? This is how we have done it, but I think I'll do that problem again for you. So you have, this is y, this is the L minus y. And L minus y is mu L. So far there is no change, and y here is L upon. Now let me work out this work done by friction. I said if this is x lambda g mu mg, that's frictional force, dx pi. So where are you getting it from? Y to 0. I think I put this as L minus y. That is not correct, because whole thing is y, now it is 0. So what do you get? Mu lambda g x dx is x square by 2 and you have y to 0. So mu lambda g into minus you will get y square by 2. It is not L minus y whole square that I got it for you. So you have to be careful in reworking this problem. So this is, I was getting some doubt. Work done by friction is minus mu lambda g y square. Work done by gravity. What is work done by gravity? I know that this is minus initial P is minus L minus y whole square lambda g by 2 minus L square lambda g by 2. This minus, therefore this becomes plus L square lambda g by 2 L minus whole square lambda g by 2. Alright. Now sum of these two, that is mu lambda g y square by 2 plus lambda g by 2 L square minus L minus y whole square, isn't it? L square minus L, all this is equal to half mv square. There is the difference is only in this, not in the rest of the things. So 2 gets cancelled everywhere, and well, now we can substitute lambda also gets cancelled everywhere. So v square is equal to g by L. What are you getting? L square minus L minus y whole square minus mu y square, because 2 factor all got cancelled. Now this is the answer actually. Now you see L square. Now what do you get here? Minus L square minus y square, isn't it? Minus 2 is plus 2ly minus y square mu. Okay, L square gets cancelled. This is, what do you get? G by L into 2ly minus y square into 1 plus mu. Because I combine this, that you get 1 plus mu. All this is v square. Now you substitute what is y. G by L 2L L square by 1 plus mu minus y square L square plus mu whole square into 1 plus. So this gets cancelled. Alright? Now that leaves you with L square also you take common. L into 1 plus mu denominator. So you get 2 minus 1, isn't it? So you get GL by 1 plus mu. I am purposely retaining all this in the video. I could have edited this, but it doesn't matter to me. See, anyone can commit a mistake, but you see that, how quickly I have got back to that. This is where your wisdom lies. So I don't want you to edit the whole thing and say this one is correct, and whatever the teacher does all the time is correct is rubbish. I don't want the teacher. You should have everything in your mind of what to do. Then you will understand, you will get it. Okay? So, the previous answer that we got was wrong because instead of y, we took L minus y as the limit. There is nothing else. So, what an interesting case that you have here. So, if friction is involved, what will be the velocity with which it will move when, of course, the last link leaves the chain? In the case of smooth surface and in the case of rough surface. There's a lot of difference between the previous. There when the whole chain was lying on the table. So you can't compare just like that. Okay? Fine. Now let me tell you. I want you to work out. This much of length is hanging. Now suppose this is smooth surface. Well, this is smooth surface. Let me say this is L minus 1, this is y. So total length is here. Now how do you work out what will be the velocity when the last link changes it? Very simple. Work done by gravity. Work done by gravity, how do you do that? L square minus L minus y whole square into lambda g by 2. What work done by gravity? This is equal to, because there is no work done by friction. So, the total length, what is the total length? L lambda half m v square. So 2 gets cancelled if the surface were to be smooth and vertical. So what do you get here? Of course lambda, lambda gets cancelled. So v square is equal to g by L. Now this is as before, L square minus L square minus L square. So L square gets cancelled. G by L, I can take y common. So you get 2L minus y. This is how you are getting the answer if it were to be smooth. But I don't know what is that y. But y is L by 1 plus b. Just like it, we'll substitute. G by L. What is y? L by 1 plus mu. That is why we have written. Then 2L minus L by 1 plus mu. This is how you are getting it. L gets cancelled. Now L you can take common 2 plus 2 mu minus 1. This 1 plus mu also additionally comes here. So you get 1 plus 2 mu into GL by this is the difference between the two. If it were to be smooth surface, in the same scenario, you may ask me, in the case of smooth surface, how did you get your mu? Simply, the mu, let it be any constant, I am not bothered. That this hanging part is mu L by 1 plus mu, lying on the table is L by 1 plus mu, then I have allowed it to fall on its own. What is the last link once it leaves? This is the velocity. And if you have it, this is the velocity. You can very clearly see there is a hell of a difference between the two. And what is the difference? You can write root of 1 plus 2 mu by GL by 1 plus mu. So this velocity will be 1 plus 2 mu upon 1 plus mu under root times your velocity when friction is present. Okay? Right. Friction is present. Very interesting. I hope you are not confused. Let me repeat. If friction were to be present, what could be the velocity? Now, friction means I took a case where there is a maximum possible hanging length. So any little push will automatically pull the whole thing down. Though I worked it out. Suppose it will go to be smooth. Now these two velocities you can compare, not the previous one where the entire chain was lying on the table. So here now you have, this is the difference between these two cases. You could very clearly see. They may ask the ratio of the two velocities without smooth and rough, that is under root of 1 plus 2 mu upon 1 plus mu. I hope this is very clear to you. Right? Interesting. Right. Now this is one case I told you on this. Okay? Now I am now considering this part is S, this part is L minus S. Smooth. That is smooth. No problem at all. That is smooth. And obviously, if you allow it to fall, S and L minus S, what is the velocity when the last plate leaves that inclined surface? Now, the gravity is the only force that is acting, that is only for doing work. Therefore, if I take a P reference, be very careful of this reference zero. Anything above is positive, anything below is negative. What is initial sum of the potential energy? Now, since this is uniformly distributed, it's as though the whole mass is lying here, right? So this is S, this is beta, therefore this is S sin beta. And this is exactly half of it. Okay? So S sin beta lambda G by S, this is the mass. One second. Don't get confused here. Yes, lambda G, mg into height, mgh. What is this height? Yes, sin beta by 2 minus this, but this is L minus S whole square lambda G by 2. This is the total initial potential energy. Partly positive, partly negative. When you sum it up, the S is such that it could be zero, it doesn't matter. But this is the initial potential energy. Finally, it's very simple because when the whole thing is leaving, this is L. So final potential energy is L square lambda G by 2. That's it. Now you got the answer. How do you get initial minus final? Below, because the entire thing is lying below P is equal to 0, therefore negative. So the whole thing minus of minus. So L square lambda G by 2 plus S square lambda G by 2 sine beta. This is equal to half mv square. So 2 everywhere, lambda, 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 everywhere, and that's it. So v square is equal to g common g by l square plus s square sine beta minus l minus s whole square. This is the answer. Got it? Likewise, you have to find out. What if friction is present? You try to work out on your own, then I'll work out in my next class. Thank you.